Okay, so we are learning, change it up a little bit. We're going to divide a polynomial by a monomial. So when it comes to dividing, we have to recall the quotient rule. The quotient rule says that of the same base, when I am dividing, I am actually going to subtract the exponents. Okay, not add them, not divide them, but subtract them. Now, when it comes to coefficients, we simply just divide it out or simplify. So let's just go over a lot of examples, get you the hang of it. So number one, 36 over 4 simplifies to 9. And then x to the fifth over x to the third, if I subtract my exponents, that's x squared. And that's it. Number two, 18 over 6 simplifies to 3. And then now here's where I do the rule a little bit differently. What I like to do is focus on the quotient rule, the higher power. So yes, I'm still going to subtract 3 and 7, but I know that my answer is going to end up in the denominator here because 7 is higher. So 7 minus 3 is 4. So y to the fourth stays in the denominator, not the numerator. Okay, so we're going to use that from now on. 20 over 24 simplifies to a fraction of 5 over, I know it, 6. Okay, now if I look at A, okay, 2 over 3, the higher power is 3, so 3 minus 2 is 1, but it's going to be A to the first power on the denominator. B to the fourth over B to the fourth simplifies to 1, which cancels out. And then C to the 6 over C to the third, since 6 is the higher power, I know C is going to be in the numerator, and 6 minus 3 is 3. Okay, now those are just warm-up questions to the exponent law for the quotient rule. Whereas, so dividing by a monomial, okay, if you look here, it's like we're breaking it up into several pieces. So number 4, I'm going to do 6x over 3 first, and then I'm going to do 9 over 3. So I'm going to break it up by each polynomial in each monomial. So 6 over 3 simplifies to 2x, okay? 9 divided by 3 is positive 3. If I look at number 5, 40x squared divided by 8 is 5x squared, and negative 8x divided by 8 is negative 1x, or just negative x. Number 6, 7n squared divided by n. Remember, I just subtract my exponents, so it's just 7n. 4n divided by n is positive 4. Because 1 minus 1 is 0, but n to the 0 power is just 1. So 1 times 4 is 4. Number 7, 12x cubed over 3x squared is 4x, because 3 minus 2 is 1. 15x over 3x is positive 5. And, this one, so this one's a bit odd. So 15 divided by 3 is 5. So 5 is going to stay in the numerator. But because x squared and x squared is higher, so 2 minus 1 is 1. So that 1x is going to stay in the denominator. And that's it. Oh, I'm so sorry. It actually gets split up anyway because we do it separately. So 5 over x by itself, not underneath the whole thing. Okay, we'll do more like it. 10v squared over 5 is 2v squared. 5v over 5 is just v. And negative 15 over 5 is negative 3. Number 9, 18c cubed over 3c is 6c squared, because 3 minus 1 is 2. Negative 21 over 3 is negative 7. And c squared minus c is 1c. 3c over 3c, I know it seems like it cancels. This is where you have to be careful with that word cancels, because 3c divided by 3c is actually 1. So you're going to put plus 1. You don't want to put 0, so it technically doesn't cancel out. It simplifies to 1. So plus 1. Number 10, 8a cubed over a is 8a squared, and then negative 2a squared over a, negative 2a squared, 2 minus 1 is 1, so a to the first power. Plus 5a over a is positive 5, because the a's would simplify to 1, which 5 times 1 is 5. Okay, now we bring it up a little step up a little our game because this one involves 2 or more variables. So again, break it up into 2 problems here. 6 over negative 2 is negative 3. A squared over A, 2 minus 1 is 1, so A on top. And then B over B is technically 1, so we're not going to write a 1 there. Negative 12 over negative 2 is positive 6. The A's would simplify to 1, so we're just 6 times 1 is 6. And then B squared over B, 2 minus 1 is 1, so just 1B. Okay, number 12. Negative 20 over 5 is negative 4. X squared over x to the 1, 2 minus 1 is 1, so that's x. And negative 5x divided by 5x is negative 1. Because think of it as 5x divided by 5x is 1, so negative 1. Okay, 13. Okay, 14 over negative 7 is negative 2. X is 6 minus 4 is 2, so x squared. And y third to the y1 is y squared because 3 minus 1 is 2. Negative 49 divided by negative 7 is positive 7. X to the 5th and x to the 4th, so 5 minus 4 is 1. Y to the 9th minus y to the 1 is y to the 8th. Okay. 14, negative 25 over negative 5 is positive 5. X to the 4th over x squared is x squared. Y to the 3rd to y to the 1 is y squared. Then positive 30 over negative 5 is negative 6. The x squared divided by x squared is 1, which 1 times 6 is just 6. And then y to the 5th over y to the 1, 5 minus 1 is 4, so y to the 4th. 15, 20 over 5 is 4. Okay, a to the 7th and a to the 1, 7 minus 1 is 6, so a to the 6th. B to the 3rd over b, 3 minus 1 is 2, so b squared. C squared over c, 2 minus 1 is 1, so just c. Okay, here, negative 5 ABC over 5 ABC is just minus 1. Okay, if I keep going, here, 16 over 4 is 4. X to the 6th over x squared, 6 minus 2 is 4, so that's x to the 4th. Negative 12 over 4 is negative 3. And x to the 4th over x squared, 4 minus 2 is 2, so x squared. 4x squared over 4x squared simplifies to 1, so positive 1. Okay, number 17, 12 over 3 is 4. C to the 5th over c squared, 5 minus 2 is 3, so c to the 3rd. D to the 4th over d to the 3rd, 4 minus 3 is 1, so d to the 1. 18 over 3 is positive 6. C to the 4th over c squared, 4 minus 2 is 2, or c squared, sorry. And d to the 3rd over d to the 3rd is 1, but 1 times this is just 6c squared. Okay, 18 negative 24 over 3 is negative 8. And then x to the 7th over x to the 5th, 7 minus 5 is 2. Okay, 9 over 3 is 3. Now, if you notice on this one, 5 is bigger on the denominator, so the 3 is going to have x squared in its denominator. Negative 15 over 3 is negative 5. And again, if you notice that the denominator, the 5 is bigger than this 1, so 5 minus 1 is 4, but the x to the 4th is going to remain in the denominator because 5 was bigger. So it looks a little odd, but it's pretty simple. Okay, 3 more. 15 over 5 is 3, and x to the 5th over x to the 4th, 5 minus 4 is 1, so just 1x. Negative 25 over 5 is negative 5, and since the 4 is bigger than the denominator, 4 minus 3 is 1, but that x to the 1 is going to remain in the denominator since 4 was bigger. Okay, 5 divided by 5 is positive 1, and since 4 is bigger than the denominator, 4 minus 2 is 2, but that x squared is going to remain in the denominator for that positive 1. Okay, 2 more. 28 over 4 is 7. X to the 5th over x squared, 5 minus 2 is 3, so x to the 3rd. Y to the 4th, y squared, 4 minus 2 is 2, so y to the 2. Z cubed over z squared, 3 minus 2 is 1, so z. On the right side, 8 over 4 is positive 2. X to the 4th over x squared, 4 minus 2 is 2, so x squared. Y to the 3rd over y squared, 3 minus 2 is 1, so y. Z squared over z squared is technically 1, but 1 times that is just that, so 2x squared y. Last one on the front, 30 divided by 3 is 10. C to the 5th over c squared, 5 minus 2 is 3. D to the 9th over d squared, 9 minus 2 is 7. On the middle, negative 12 over 3 is negative 4. C to the 4th over 2, 4 minus 2 is 2. D to the 8th over d2, 8 minus 2 is 6. D to the 6th. On the end, 3 over 3 is 1. C to the 3rd over c squared, 3 minus 2 is 1, so just 1c. D to the 7th over d squared, 7 minus 2 is 5, so d to the 5th. Okay, on the back side, this is just taking that same idea, but it is using the area formula for a trapezoid. So the area formula for a trapezoid is 1/2 base 1 plus base 2 times the height. Which is the same thing as dividing all of this by 2. So that's what we're gonna practice here. So if I look at it, base 1, which is, we can call it the top, x squared minus 6x minus 3, plus base 2, 3x squared plus 4x minus 1. And I'm going to add those two pieces together times the height, which is going to be x minus 5, all over 2. So of course you're not going to see one this difficult. I'm just going to do it for the notes purposes. So this is a quick little bonus. So first we have to take care of these parentheses at the top. We need to combine like terms. So it'll look a lot cleaner here in a minute. X squared plus 3x squared is 4x squared. Negative 6x plus 4x is negative 2x. And negative 3 plus negative 1 is minus 4. We're going to take that and multiply it by x minus 5 and then divide that by 2 later. So what we have to do here is what we learned recently, taking a binomial times a polynomial. And I'm going to use the box method that we learned. So we have 4x squared minus 2x minus 4 times x minus 5. So 4x squared times x is 4x to the 3rd. Negative 2x times x is negative 2x squared. Negative 4 times x is negative 4x. 4x squared times negative 5 is negative 20x squared. Negative 2x times negative 5 is 10x. Negative 4 times negative 5 is positive 20. Okay, your diagonals are your like terms, so I have 4x cubed. Negative 2x squared plus negative 20x squared is negative 22x squared. 10x minus 4x is positive 6x, and then plus 20. But again, we're going to divide all of that by 2. So 4x squared, 4x to the 3rd divided by 2 is 2x cubed. Negative 22x squared over 2 is negative 11x squared. 6x over 2 is positive 3x, and 20 divided by 2 is positive 10. So after all of that, we end up with a simple polynomial. Again, you won't see this one this difficult, but it's just something, a skill to learn.